Okay, so in this problem we're doing some scattering. So the first problem he asked us to do is looking at the inverse process of what we did before. So this time it's a particle in it, a particle pair, annihilating into a particle. So, spoiler, because this is just the opposite of what we did before, the conjugate amplitude to the process we looked at before, we're going to get the same thing that we got before. And it works out in a very similar way. So I'm not going to go too much into it. I did work out the details if you want to see them. But, basically you just work with, you break it up into parts. You write out the initial state first, leave the final state alone. And then my psi and psi dagger, they will only, the only terms in them that will contribute are the ones that I need them to annihilate, this B and C. So my psi will have the B term, my psi dagger will have the C term. And once I plug in my Fourier expansions for my fields, I can write out this term like this. And, once you've done this enough, you get pretty good at just going from this expression directly to this. And then this expression looks horrible again, but all we have to do is commute our C's and B's, and just get delta functions, and pretty much everything goes away, except for this exponential. And then I just have to deal with the phi and final state terms. And again, I'll just end up doing some commutating and end up with this, which is what we got before. And the Feynman diagram looks like this, just flipped around from the previous one. And obviously, just from this, there's no, if you flip it around, you get the same value. So we could have predicted this without doing any math, but, whatever. It's not too bad to do this after you've done it before. So the more interesting problem is the second one, where we're doing scattering between an A particle and a B particle. So I have these two, these are my initial state and my final state. And we can see that the first order interaction term, we can't go from this state to this state with just this, because we need to destroy an A particle and destroy a B particle, create an A particle, create a B particle. Here I can only destroy a B particle, create a B particle, and destroy an A particle, but then I couldn't create another A particle. So I need my second order term. And again, the time ordering of this will involve all those contractions. But since we know we need 4 fields acting, because we need to destroy 2 particles and create 2 particles, the only terms that could possibly contribute are the ones that involve a single contraction of our pairs of fields, and which there were 9 of that we found before. And it's clear that the only ones that are going to contribute are ones where I contract a psi dagger and a psi, because I will leave over, I'll have left over what I want, a phi 1 and a phi 2 to create and destroy an A particle, and a psi 1 and a psi, or a psi and a psi dagger to create and destroy a B particle. So I'll have these two terms, and it's, since we're integrating over dx1 and dx2, these are symmetric under the exchange of psi 1 and psi 2. And then because they're in this normal ordering, I can commute them. So if I basically, the contribution of this term will be the same as the contribution of this term. So I can just worry about one of these and just double the answer I get. So that's what we'll do in the next video.